Okay, so in context of yesterday, where I was gone because I'm still recovering from quite a few things that are going on. You don't need to know all of them, but I don't think I have a broken rib, but it is badly bruised, and that makes sleeping very difficult. And it also, when yesterday I was coughing and sneezing all day, you can imagine how painful that is. But anyway, I'm back, and I'm going to review a little bit for you. This is not something we've talked about in a while. Why are we doing this? Because during the second semester, we have found that if we keep on reviewing the stuff from a couple chapters before, your final won't be nearly as painful to review for if we just keep touching this stuff. So, do you remember the skill of replacing everything with sines and cosines? Take this and replace them with sines and cosines. Now, you might think, why would I do that? Because I don't even have sine or cosine. But those also could be sines and cosines, couldn't they? So anyway, replace this with a sine and a cosine. It's a good question. You will have a sheet on the test, so I guess it's okay, but I really hope you know these. Let's see how many of you know. Tangent is what? Sine over cosine. Good. And cosine is then cosine over sine. If it's the flip, right, it should just be cosine over sine. But what's the problem now?
You have to make
a common denominator. That's another one of the big strategies in trying to prove things, is make them have a common denominator and add them. And after you do that this time, it's all going to work out real nice. Anybody need a sheet? I have extras. Just raise your hand and I'll deliver. I'll pause for a second while I have you work out. Okay, so next step is multiply by sine here and by cosine over here. Why did I just do that? Because now if you look at the denominators, they're identical. And they have a common denominator. So now I can actually add the tops, which are something. Sine squared plus cosine squared. I feel like I recognize that one. Sine squared plus cosine squared. Where have I ever seen that before? It equals 1. That's correct. All over the denominator of sine. Oops, that's not a sine at all. Sine, cosine. And you can have them backwards, that's fine. But that top turns into 1. But how do I make it so that I have secant and cosecant? Well, secant is really what? So we're going to break this into 2 of them being multiplied. And then I'm going to switch their places. I'm going to do a double step here. And I'm going to say secant and then cosecant. And I bring the other side, which is secant cosecant, all the way down from up there. And it's identical. That's equal to that is how you end the proof. Does that ring a bell? Do you remember doing those? It involved changing everything into sines and cosines. And what's the other big step? Common denominators. And then one little knowledge of an identity, which was that sine squared plus cosine squared equal to 1. Yes?
Instead of like doing like the 2 steps of putting it back into secant and cosecant, can you just put like in parentheses?
Nope. I know you want to save time, but the amount of time you wasted in asking me that question should have just been invested in actually writing that down. You can't skip any steps. You got to go all the way to the end and say exactly the same on both sides. I even marked it wrong if people had them reversed. If you had cosecant first and secant second, that's not identical. It has to be identical here and here. And you need every step leading up to it on a proof. All right, let's also do a little bit of review of graphing. Do you remember what to do if I said 2 tangent of 3 theta? If you had to graph that, I hope you remember what the parent tangent looks like. And then you got to do some stretches and stuff. I'm going to pause for a second while you give that one a try. Okay, so hopefully you remembered tangent looks like that. And there were a few important spots along the way. Pi over 2 and negative pi over 2. And then the spot that's halfway in between is also important. If you don't think that's true, then you aren't thinking about how that spot is important. That spot's 1, and then we need to know where it hits it at 1, and that's this, which is half of pi over 2, so it's pi over 4. And this one's pi over 4, and then it hits right there at negative 1. I just graphed parent tangent there. So now what do I got to do? I'm going to call on different people and have them tag team this question. Row 5, last person. How do I start? Which, oh yeah, there's one in the front. Yep.
Is that the one where it's like up to?
Yep. So the y-axis changes to 2 and negative 2. Raise your hand if you had that part right. Good. And then dice of destiny, row 3, person 3. That's you, Mr. R. What do you do next? We've handled this part. Okay. So you're multiplying everything by 1/3 is correct. Is that your watch, actually?
Yeah, it's our watch that triggered my phone and played music.
Okay. You have something special happening right now? Okay. So it's pi over 6 and pi over 12 and negative pi over 12 and negative pi over 6. How many of you guys would think you got that stuff dialed in? Okay, good. Now what if I ask you to shift it? If I had put this as minus pi over 6, do you get the whole thing? Everything, including the asymptotes, would have shifted where? Right. How far? Pi over 6. And how far is pi over 6? Well, that's how far pi over 6 is. So I need to shift that far, which I guess you could say is 2 marks to the right. Yes, sir.
So because of 3 is outside of the theta.
It has already been factored. Had I given it to you like this, then I would have told you, you have to factor it. But since I wrote it pre-factored, you don't have to worry about that.
So do you? Okay. So when it's inside, you have to do the translation first before you do that, right?
Okay, so the way we want you to know this is, if we give it to you this way, then you will have to factor it, but we want you to always do your renumbering first, which is what will happen when you do this in the right order. Once you've got it factored like this, that's normally first because it's in parentheses. That forces you to do that part first, which is the renumbering part. So yeah, you'll have to do the renumbering first. Had you done it this way, without factoring it, it is possible, but I don't want to try to teach 2 ways of doing it. But if you really wanted to do it, then what you'd do is don't renumber it first, you'd do that first. And then you would go back and renumber it. So that would be a different way to get to the same answer. I always want you to factor it first and then do the renumbering first. Okay, good enough on the review stuff from that. Now here's some review from just yesterday. Now here's what I was trying to teach you. If you had this, it's supposed to be super simple by now. You've got 2 answers for that. But if there's no restriction on how many answers to give, you actually have unlimited answers for this. So you start by writing what the 2 answers are, and you put plus 2, what? 2 pi k. Very good. Go ahead and do that. We'll start with the simplest one, just that. Find your 2 answers for that. And then I'll show you how it would have been different when it was a little more complicated. Starting off with an easy one. Okay, I should have said sine's positive, so it can't be here and it can't be here. And then, if this is, or one of my answers is, sine is opposite and hypotenuse, that's root 3. That means that's a 30-degree angle. Then there's another one over here. 1, 2, root 3. This one's negative, though, this time. And then it's also a 30-degree angle, but we use pi over 6, 1 pi over 6, and 5 pi over 6. So theta equals pi over 6, and theta equals 5 pi over 6. Raise your hand if you had that one right. Okay, good. Now, how was it more complicated yesterday? What was different? It would have said sine of 3 theta equals 1/2. All right, that's something I taught you at the very end of the hour. Now, if you didn't catch it now. What I recommend you do is act like the problem doesn't say 3 theta. Just act like it says theta. How can you do that? Well, you can do what's called a U substitution. You can say, I don't want it to be 3 theta. I want this to just be theta. Or, in this case of a U substitution, I want to not say 3 theta. I want to say U. Okay, so that's let U equal 3 theta. You remember that? Okay, so now that makes my life easier because I can just act like it's this easy problem and I'll be done. U equals these two things. All right, but, it's a big but, you can't just stop right there. You have to go now and finish it because you said that 3 theta was U, so then U is 3 theta. See what's happening here? I'm replacing my U with a 3 theta, and then replacing this U with a 3 theta. And then, how do I get the all solutions part? By going plus 2 pi k, plus 2 pi k. And then, the final answer is theta isn't alone yet. I got to multiply everything by 1/3. And then theta is alone, and it's pi over 18 plus 2 pi k over 3. That's a 1 times there. And there's a times there also. And this will be, and these cancel, theta equals 5 pi over 18 plus 2 pi k over 3. That seemed like a really complicated answer? It is. But you're in a really heavy-duty class. Regular pre-calc would not have done that. All right. So let me do one like that for you and see if you could have handled this. Maybe you could have done it without that preface, but we'll see. Cosine of, how about we make it a little more interesting, 6 theta. Point is, it doesn't have to always be a 3 there, just something complicated, is equal to negative 1/2. So first, let U equal 6 theta. And I'll pause while you give this one a try. Okay, I'm going to get started at least. Let U equal 6 theta. So right off the bat, you make your life easier. Then, cosine this to be negative. So it can't be here and it can't be there. Is this an inverse cosine question? Nope. Nowhere on here does it say arc cosine or cosine with a negative 1. So we don't have the extra restrictions like cosine can only be here. Nope, we don't have that rule. So we can have 2 answers. One for this and one down here. Okay, cosine adjacent, hypotenuse, and adjacent, hypotenuse. Then, if I wanted to know what angle this is, I can just look across from the root 3 is always a 60, so that's a 60, also known as a pi over 3. But that's not really pi over 3, it's a bunch of pi over 3s to get there. So it's U equals 2 pi over 3. Raise your hand if you had that, one of the 2 answers. All right, and then the other one is 4 pi over 3. But there's a couple little crucial elements. Random dice, tell me who I should talk to. Dice of destiny. Row 2, last person. This is not the final answer. Tell me what to do. Exactly, plus 2 pi k in both of these. That tells us the rest of the answers. And now we have to fix something else. Dice of destiny. It's row 5. Last person likes you today. Why can't I just leave it like this? Yes, that 6 theta was what was there in the first place. Has to come back to haunt us. So we're going to replace the U with 6 theta. And then, how do I finish it?
You divide, or multiply, divide
By?
6. Multiply by 6.
Give me your final answer.
2 pi over 18
Can be reduced, but I won't quibble.
plus
also can be reduced. And final on this one.
4 pi.
You got it. Those need to be reduced a smidge, but other than that, you're good. Any questions? All right. So I changed it from a 3 theta to a 6 theta, but do you get it was essentially the same problem as last time? All right, let me add one more twist. What if it was sine of 2 theta minus pi over 2 equals negative 1/2. That looks really complicated. So, use a u substitution. It's still the same thing. It's just u substitution. It's just when you substitute at the end, you'll have this icky thing for u. All right. Pause for a minute while you give that one a try. Okay. All right, so we're back, and we're letting u equal that. So now I can draw my triangles in the opposite side, negative 1, on the hypotenuse side 2. This one's root 3, and negative 1 and 2 and root 3. Okay, so I'm going to get two answers here, and they're both, the ones across from the 1 are pi over 6s. But it's a whole bunch of pi over 6s. This is 7 pi over 6, and this will be not 12 pi over 6, but 11 pi over 6. So 7 pi over 6 and 11 pi over 6. That's a start. It's not done, but that's a start. Now, what are some things I've forgotten? Well, first of all, these were u's. Okay, next, I got to remember the plus 2 pi k thing. How many guys remembered your plus 2 pi k piece? All right, good. And then I got to get this to actually be what I said it was going to be. U is actually, over here, 2 theta minus pi over 2. Now, I bet you right here, a lot of you are going to goof up. Does anybody see the thing that the people are probably going to do wrong? You want to make a prediction? I've been doing this long enough, I have a good guess anyway. That people are going to go, okay, you're trying to get theta alone, so we should add pi over 2 to both sides. So here's what people do. You go plus pi over 2, that's right. Plus pi over 2 plus pi over 2. See anything wrong with what I just did? Yeah, you can't add it to everything. You're just going to add it to one on each side. This part was fine. That cancels that. But you can't add it to both. That'd be like this. 5 does equal 2 plus 3. But then if I add 1 to both sides, that'd be like doing this. Does that really still work? No, can't do that. When you're adding, you only add a 1 on each side. Now that would still be true. Okay, so same deal. I can only add 1 of these. So which one do I want to add it to? Well, that's not going to be very easy to add pi over 2 there. So I'm going to not add it there. I'm going to add it here. 7 pi over 6 plus pi over 2. I got to get a common denominator. All kinds of pain and suffering ensues here. We got to get 3 pi over 6 plus the 7 pi over 6 makes 10 pi over 6. All right, so now this part right here has become 10 pi over 6. I better rewrite it down here. Plus 2 pi k. And that's still not solved. It's 2 theta equals all that. So then I have to get rid of the 2 by multiplying everything by what? Come on. 1/2. 1/2. 1/2. And then the final answer here would be 10 divided by the 2 makes 5 pi over 6 plus pi k. 2's would cancel. But this guy, I'll have to do all those same steps to that. I'm going to add pi over 2 to both sides. That's really 3 pi over 6 added to the 11 makes 14 pi over 6. So now my 14 pi over 6 plus 2 pi k has to all get multiplied by a half. And 14 pi over 6 plus 2 pi k has to be multiplied by 1/2. And those will cancel. And this will become 14 pi over 12. Or another way to say it is 7 pi over 6 plus pi k. If you're wondering if that's like normal, no, this is really hard. We're going beyond where regular pre-calc would be for sure, and we're going faster. So this is tough. But on the positive side, you are going to be done with your, I believe this is your last regular trig test. And then I think we have 4 of those little units at the end that are bonus add-on things you only get at honors, like polar. That'll be a super simple one. Anyway, so you got some easy tests coming, but this one is not an easy test. And it's coming on Tuesday. Okay, so try to if you could lock in a good grade on this one, I'll go from the positive angle here. If you could lock in a good grade on this one, then it's going to be smooth sailing until the end of the year. Because if you're smart enough to get an A on this test, then the next few are going to be like welcome reliefs. But if you get the B or the C, this is a tough test. We got easier ones coming. All right, so that covers almost everything I needed to teach you. You know, if I put in a weird thing where the angle should be, I hope you're getting the idea. That all you have to do is replace this with U. Solve the problem, then swap it back in and finish the deal. Okay, so how about this? What if you asked to solve that? Remember the saying, if you can factor it, you should? They've already factored it. Why is it good to factor something? Because then stuff cancels, but nothing's canceling here. But something also happens. Do you remember, I'm going to make this is a flashback to when you were in life was good and easy in honors higher algebra. You would have factored it and got this. And then you would have just said, oh, so there's 2 answers. One's 3, one's -3, because that's the 2 things that make it 0. Back then, you only had like 2 steps. Now we have like 9 steps to do a problem. So everybody has trouble when you move up to pre-calc, whether it's honors or regular, because there's so many more steps, so many more little pieces to remember. Okay, but this, you would have just had something, and then you'd factor it to this, and then they just jump right out at you. Oh, -3. What if this had been 2x plus 3? Well, then you'd set it equal to 0. 2x plus 3 equals 0, and x minus 3 equals 0, and you have 2 little mini equations to solve. Okay? So how is this like that? Because that equals 0, or that equals 0, and that's 2 equations to solve. But in pre-calc world, when you just have to solve this equals 0, it's not quite so easy. Sine theta minus 1 equals 0 is actually sine theta equals 1, which actually has multiple answers sometimes. And this one involves quadrantals. So sine is which one? Sine's y. So which of these spots am I at then if y equals 1? This one here? All right. And what is that spot? What's the angle? That's not 0. If you're up here, this is the spot 0, 1, and that's the y is 1, and that's pi over 2. Pi over 2 is right there. So the answer to this part is pi over 2. How about this other part? Sine theta equals -1. Again, you can draw pictures for these, and sometimes you'll just get one answer, but imagine for a moment a scenario where it was two sine theta minus 1. Then do you get, I'm going to have sine of theta equals 2 sine of theta equals 1, divided by 2, divided by 2, and sine theta equals 1/2, and you'll get 2 answers again, because you'll have 2 triangles. So I could have two answers for this side, and I could have two answers for that side. We could even make your life so complicated as to say, like, 3 sine theta minus 1, and 4, actually we wouldn't do that one, we would do root 2, though we could do that, and 4 tangent theta plus 1, and then sine, how about a cosine? Cosine of theta minus 1 equals 0. Then you could get two answers for this one, two answers for this one, and one answer for that one. You'd have 5 answers for this problem. Okay. So if you can factor it, you should thing comes up because we want to get this set up. We would even be as evil as having all of this, except it isn't factored. And you have to factor it first to get it to that. So let me show you how that would look. Sine 2 theta equals cosine theta. There. It looks deceptively easy. Who can tell me something they know? Because it's just like, oh, I remember this one. You know something? What?
Sine
2 sine cosine. Awesome. Good start. Now what? We want to get this so we can factor it and set it equal to 0. Remember? It sets a parentheses equaling 0. What? Subtract cosine from both sides. Why is that good? Because now the right side just has 0. And on the left side, we have something kind of icky. But then my favorite saying comes into play. What is my favorite saying? Can factor it. You should. And see how there's a cosine of both of them? Comes out to the front. Cosine theta, and then I got 2 sine theta minus 1 equals 0, and now, see what just happened there? The 2 cosines just got factored out to the front, and now that can equal 0. Isn't that an equation that you could just say, yeah, x equals 0. Somewhere on a quadrantal that would work. Some angle would make that work, and some angle would make that equal 0 too. So you'd have 2 sine theta minus 1 equaling 0, which is like 2 sine theta equaling 1, which is like sine theta equaling a half. And we've done that one like 6 times. It's got 2 answers, and one of them's 30 degrees or pi over 6. Okay, so that's the last kind. Now the good news is the only thing we have now is little tweaks to make your life a little more complicated than that. Like, what if we don't use cosine? What if we use secant? Okay, well, secant is just a flip, so then you'd have to do one extra little thing. Okay, what if we don't use sine? What if we use cosecant? So then you'll have to just, okay, I can't really do cosecant, but I can get it down, and then instead of having cosecant equaling a half, I'll have to flip it and make it sine equals, flip that, 2. Well, what's wrong with that? What if it was sine equals 2? Another thing we would be evil enough to do to you. Can sine, picture the graph of sine. Can it ever be 2? No. So what's that answer? Yeah, there is no angle that would make sine equal 2. Let's look at the graph of sine. It just goes up and down. Where 1's the highest it ever goes, it can't get to 2. So there is no angle that would do that. Okay, so I know that's a lot, but the good news is from here on it's mostly just reviewing stuff. So let's look at the homework together. Everybody find today's homework. I'm cutting it down dramatically. I'm literally cutting out 7 homework questions today out of about 14. So, okay. So here are some that you can skip. You may skip number 7. Notice it says cotangent. Cotangent of 2x. That's not even on the sheet. But what is on the sheet? Tangent of 2x. It's on the sheet. You'd find it, and then you'd have to remember to take the answer and flip it. Okay, but we're not going to do that one. It also has an icky angle here, or icky sides, because That one isn't common. What's the one that's like it? Some of you guys are getting good at this now. 1 over root 3, very good. Well, we're not doing that one because it'd have 2 double twists in it. Not necessary. That's abusive. All right, let's go to number 9. Skipping number 9. Skipping number 12. So you're doing the other 2, of course. Next is skipping number 16. It's not like you couldn't do it. By the way, how would you start it? You would take the square root of both sides. And the square root of 4/3 actually works out pretty well. What is that? 2 over root 3. And isn't that upside down from normal? Isn't normally the root 3 on top? But since it's secant, you wouldn't want to do secant anyway. You'd want to flip it over and use the sister function. What's the sister function of secant? Cosine. All right. But we're not doing that one. All right. So number 16 is gone. Also, number 24 is gone. You could have done it, but this assignment's just too long. And then we're going to skip these 2 also. Okay, now let's get to it. On number 2. On number 2, cosine of 3x equals 1/2. What if this was just a u right here? I hope you'd be able to solve it. Should be easy then, right? So let u equal 3x. And then it's just a normal one where you go, where is cosine 1/2? Cosine's positive. So it can't be here, can't be here. This is not an inverse trig question, so there's no other restrictions. So that means there's 2 answers. And it's just like we were doing before. And don't forget the plus 2 pi k thing. Okay. So this is 1. Jason, or hypotenuse 1, 2, root 3. Negative. And then I want the angles. What's across from root 3? Pi over 6. Nope. Pi over 3. And u equals a whole bunch of pi over 3's. Let me see. That's 6 pi over 3 would be 5 pi. No. Hey, am I right? I think I'm right. Okay, good. Then I got to put the plus 2 pi k. Plus 2 pi k. And then last thing, this was made simpler by letting u equal 3x. So now we have to let u equal 3x. And then solve that. I'm going to leave you something on that first one. Finish that off. All right. Next, let's talk about, these just get to be weirder and weirder things in here, but you just let u equal all that, solve it, and then swap them back out at the end. This one's kind of strange. You use square root, and then root 3 over root 4 actually works out pretty good. But here's what everybody forgets. The square root of sine squared. What is it? It is not sine. It is not the square root of sine. The square root of sine squared is not just sine. Absolute value of sine. And if it's an absolute value, why is it absolute value? Because the square root of a variable. Anytime you square root a variable, you get absolute value. That brings you 2 equations. That is the thing that keeps coming up over and over, and people get screwed up because I actually know some higher algebra teachers just go, when you're solving this, just go square root and then put plus minus. That's what's messing you up. I taught algebra for a long time too, and people just think, oh, I just slap a plus minus on it, it'll be fine. That's not what's happening. What's happening is, when you square root x squared, it's the absolute value of x. And the square root of 16 is 4. It's not a negative 4. The reason there's a negative is because that's an absolute value problem, which splits into 2 parts. Okay, so you need to understand this. That's why we keep bringing it back up over and over and over, that it's an absolute value when you square root a variable. Okay, then on number 20, hint, that's on the sheet, right? And you're going to want to get it all onto one side so that you have something factored equaling 0. That's the hint I'm going to give you there. All right, I think that makes it a doable assignment. You got some time to work. If you need help, I'll be up here in front.